Okay, so in our last video that you did in part 1, we talked about conditional statements, which were basically if-then statements, and then we talked about the converse, inverse, and contrapositive. Today we are going to talk about what are called biconditional statements, and biconditional statements are also known as if and only if statements. Okay, and when we write if and only if, we can also just abbreviate that to IFF. That means the same thing. So here's what that's actually going to look like. Okay. But first of all, we're going to do a little reasoning here. Kind of go back and think a little bit about the things that we know and how we can actually decide whether or not something is true. So in this diagram I have at the right is two lines that intersect. I have some labels in there that indicate angles. So this would be angle 1, angle 2, and angle 3. And what we need to decide is whether or not we can look at the diagram with only the markings that are there without making any assumptions and decide whether or not each statement is true. Okay, so if we look at the first one, angle 1 and angle 2 are supplementary. First thing we have to know is remember our definition. What does supplementary mean? Supplementary means the two angles add up to 180 degrees or make a straight line. And if we look at this diagram, angle 1 and angle 2 make a straight line. So we can say that that statement is true. Okay. The next statement says that M is the midpoint of FH. Okay, so here is segment F, H right there. Here is M. Okay, it might look like it's the midpoint. Is there anything that indicates that it's the same? Is there anything that says that those two parts are the same? Whether it says that FM is 10 and MH is 10 or anything like that. So if we look at the diagram as it is, there is nothing that tells us that is a fact. So if it doesn't tell us that, we can't assume it. So we might look like it, but it is not actually the midpoint. So that one would be false because there's not enough information. Angle 1 and angle 3 are vertical angles. So if you remember, vertical angles are when two lines intersect, the angles are across from each other. And angle 1 and angle 3 are across from each other in that diagram, which means they are vertical angles, which would make that true. And then the last one, FH, this sign right here says perpendicular. Okay, so if you ever see that sign, that means perpendicular. Okay. And in order for something to be perpendicular, they have to intersect at a right angle. And in order for us to know that things intersect at a right angle, it will always have one of two things that are going to be in the diagram. It'll either say that this is 90 degrees, or it'll have a little red square in the corner. And if you look at this diagram, there's neither of those things, and you can look at it and tell also that they are not perpendicular. They don't meet at a right angle. But if it looked like they did, if they don't have either of those things in the diagram, the 90 degrees or the little red square, then you cannot assume that that is true. So that is false. Okay, so now we're actually going to go back to biconditional statements. Okay, a biconditional statement is when a conditional statement, which was that very first, okay, statement was true, and its converse. Okay, so that means just flipping the order. Okay, so if then, and then just flip the order of the hypothesis and the conclusion. If those are both true, then it's called a biconditional statement. And we say that it is if and only if, and then, or you can have the little arrows going both ways in between. So if and only if can be shortened to IFF. I kind of talked about that in the first slide. And then biconditional statement means that if P then Q is true, and if Q then P is true. They both have to be true in order to write a biconditional statement. So let's take a look here, okay? It says rewrite the definition of perpendicular lines as a single biconditional statement. So we have a conditional statement. The conditional statement is if two lines intersect to form a right angle, then they are perpendicular lines. That is true, okay? If they form a right angle, that's the definition of perpendicular, then they are perpendicular lines. So then we need to decide if the converse is also true. Okay, and the converse would just be flipping the order. If, I'm going to kind of make it a little bit shorter, if perpendicular, if the lines are perpendicular, then they intersect at a right angle. Okay, is that true? Okay, well, if they are perpendicular, that's pretty much the definition of it, is that they intersect at a right angle, so that is also true. So when we write a biconditional statement, we take out the if and the then and just make it into one statement, okay? So we would have, let's see, if, no, we don't write if, because it's if and only if, lines intersect at a right angle. I'm going to abbreviate that as an angle. If and only if they are perpendicular. Okay. We also could have wrote this biconditional statement as lines are perpendicular. I'm going to use that abbreviation as perpendicular. Lines are perpendicular if and only if they intersect at a right angle. Okay, so if you notice in my biconditional statement, I have the if part and the then part in there. I kind of had to reword it just a little bit, but it's all in there. Okay, you don't start a biconditional statement with if. You start the biconditional statement with the hypothesis, if and only if, conclusion. Or you can go the other way. You say conclusion, if and only if, hypothesis. Okay. Okay, so we're just going to practice this a little bit more in here, maybe. Okay, rewrite the definition of a right angle as a single biconditional statement. So if an angle is a right angle, then its measure is 90. The converse would be if, I'm going to kind of make it a little bit shorter, 90 degrees, then right angle. And we know that that's true. Okay, so the biconditional statement would be a 90-degree angle. Oh, excuse me, I put that a little bit wrong. An angle is 90 degrees. If and only if it's a right angle. You could also say let's see, rewrite the definition. Okay, so the next one is going to be if two line segments have the same length, then they are congruent. The converse would be if two segments are congruent, then they have the same length. So we would say two segments are congruent if and only if they have the same length. We also could say if, two segments have the same length if and only if they are congruent. So we also could say two segments are congruent if and only if, that IFF, they have the same length. All right, again, we are just practicing this again. It's just a couple more times. If you want to pause the video and try it on your own to make sure that you are writing them correctly, please do. This one already has the conditional statement and the converse written for you. So if Mary is in a theater class, then she will be in the fall play. If Mary is in the fall play, then she must be taking theater class. Okay, so if you want to write an if and only if statement, you would say Mary is in theater class. If and only if she's in the fall play. You could also say Mary is in the fall play if and only if she's in theater class. It goes both ways. Rewrite the statements as, again, if you can run for president, then you're at least 35 years old. If you're at least 35 years old, then you can run for president. Okay? So we would say, you can run for president. Again, it does not start with an if statement here. You can run for president if and only if you are 35 years old. Okay, so that's how these biconditional statements work. You just have to think about how to word it so you have both parts, the conclusion and the hypothesis, on each side. Okay, and then this just circles back to what we did in part 1, just to make sure that you remember. So you can go ahead and pause it, and you can write those, and you can kind of see if you can remember the converse, inverse, contrapositive. Okay, so this is what we should have come up with. If snow is falling, then it is winter. Well, I think we decided in the very first slide back there that that's a false statement, because it could fall in really probably any time but summer, and it depends a little bit on where you live. If it is winter, then snow is falling. Well, I'd say that is false, because I mean, there are lots of days in winter when there is no snow falling, so that one would be false. If snow is not falling, then it is not winter. Again, if you think about that, that is also going to be false. And if it is not winter, then snow is not falling. Also false. And remember, you can always check yourself that you're right, because you should have things that match up. Okay, the conditional and the contrapositive will always match up. If one's true, the other's true. If one is false, the other is false. And then the other ones that match up are the converse and inverse. If one's true, they're both true. If one's false, they're both false.